Hello my students, welcome. Now we are going to learn the relativity concept. Actually, Einstein relativity concept dealing inertial frame and a non-inertial frame. Here we are dive into kinematics. So before understanding kinematics, we need to understand the frame of reference, okay, and what inertial frame, what non-inertial frame. We are going to know about it. And one more thing, it is very important. The relative motion, we must understand with what frame of reference we have and whatever things in and around of this concept. Okay, now we need to understand about frame of reference. The axis, y axis, this is x axis, this is z axis, three-dimensional axis is 0. This is reference axis with which we can specify the object position and motion. Clear? Thereby, the axis or point from where the observer can take the measurement is called frame of reference. Frame of reference can be anything. It may be bus, it may be earth, it may be a moving car, it may be lift, anywhere the person standing on that and noting the other object position and motion. Clear? It says it's like a Cartesian coordination system. It is x, it is y, it is z. Clear? When time is attached to this frame, it is very crucial to understand about what is relative motion. When for example a person walking on the moving train is at a rest relative to the train. When we are at moving train, when we are on board train, the person roving in and around the train, we can understand the person is moving. Here, let's say that train is a frame of reference because a person walking on moving train. So with respect to train taken as a reference, that is a frame of reference, the train moving in uniform velocity, so it is taken as frame of reference. Now within the train, in the any object moving can be noted down. That is we can understand the velocity, but it is very different from the point of understanding and point of perspective from the person who's standing on the outside of the train, standing on land and watching what happening inside the train. Clear? Let's say the person moving on the train and dropping the stone outside. Clear? The person will observe the stone will fall vertically downward, but the perspective of the person who's standing on the outside of the train will observe the stone motion as parabolic. Clear? Observation at the station, observation on train. This falling, the path of falling of stones from this different person, different perspective. Clear? Let's say it is ship sailing on the water from this way. Clear? On watching from the sky, I'm watching here on the land. I'm just noted down this moving along this way. I'm watching from here. I'm noted down moving along this way only. Clear? So this distance is S2, this distance is S1, this distance is S. Actually the ship moving along this way when I am watching from the sky, watching S, from the land on left side watching S1 distance, and apparent distance from this way, time taken from position A to B actually is T. Clear? This time taken will be T1, this time taken will be T2, all are different, so time also relative. Clear? So we must understand about this scenario. Let's say this scenario, bus is moving with a uniform velocity, says 30 km along straight line. Observer A sitting inside the bus. Observer B standing on the roadside. Clearly, he is at rest. Imagine dog is running inside the bus with a velocity 5 km per hour. Actually, inside the bus, observer can watch the dog will move on 5 km per hour only. But observer on the land who are at rest will watch dog is appear to be 35 km per hour. Actually, bus is moving 30 and the dog is moving 5. Experiment performed in bus, so bus is taken as a frame of reference. If the experiment performed in classroom, the classroom is taken as a frame of reference. If experiment performed in ship, the ship is taken as a frame of reference. Clear? The frame of reference must be anything and should be at rest or at uniform motion. The frame of reference should not be acceleration. Clear? The types of frame of reference: inertial frame of reference, non-inertial frame of reference. Clear? Inertial frame of reference, which obey the Newton's law of motion, is called the inertial frame of reference. A body remain at the state of rest or uniform motion in same direction unless until the external force acting upon it. Clear? So this is called Galilean and Newton frame of reference. Inertial frame of reference, Galilean Newton's frame of reference, because it obey the Newton's law, inertial law. Clear? Inertial frame of reference. Clear? Inertial frame of reference. It is nothing but the second in Newton's second law, F equal to ma. Force applied on the body is 0. Then the acceleration produced by the body is 0. But the mass is not equal to 0, because inertial frame of reference should be at rest or in uniform motion, not accelerated. The Newton's second law, F equal to m into a, there is no acceleration, so force acting on the body is 0. So the inertial frame of reference is also known as non-accelerating frame. It is very important. Non-accelerating frame. So inertial frame is also called non-rotating frame in case of rotational motion. It is now we are dealing rectilinear motion. In case of rotational motion, inertial frame is called non-rotating frame. Clear? Now we know about non-inertial frame of reference do not obey law of inertia. Clear? So frame of reference which does not obey the Newton's law of motion is called non-inertial frame of reference. Non-inertial frame of reference. Non-inertial means a frame of reference which does not move with uniform velocity, always accelerating. The frame of reference goes with accelerating. Here acceleration of the body is not equal to 0. Not very important, we must note it down. Non-inertial frame of reference. Force applied on the body is 0, but acceleration is not a 0. Clear? How it is very confusing. You know, force applied on the body is 0, but acceleration is not 0. Suppose actually imagine that you are on traveling bus. When it's near to you, the ball is lying. The bus is traveling with a speed of 100 km per hour, constant speed. So you might see the balls lying on the same point. There is no forward motion, there is no backward motion. Suddenly the driver must apply the brake because of inconvenient. Now the balls moves forward, but bus get deceleration, ball get acceleration. In this event, there is no force presence on the ball, because acceleration deceleration cancel each other. Now also the force acting on the ball is zero, the same as that the bus is moving on constant speed. When the bus driver applying the brake, the ball get accelerating, the whole system will get decelerating. Clear? But acceleration deceleration cancel each other, so there is no force acting on the ball. When the driver accelerate the bus, the whole system of bus will accelerate, but ball will get decelerate. Here the same will goes to the ball. Now acceleration deceleration cancel each other, the ball having no force. So thereby we can understand that force is zero in non-inertial frame. Clear?